AC 111 Lecture 9 Set 2, Ports Connection in System Verilog. So far we've seen how you could actually declare inputs and outputs to the modules, and then we saw one example how we could connect ports, and there are basically two ways to define connection to the module's instance ports. One is the way we just saw in the previous example. Basically, we connect by the port order. It's also called the positional port connection. The other way is to use a method called port name or named port connection. And named port connection can take a few different ways. There is an explicit named connection, which we will be covering soon. Then there is .name connection, .star connection, and so on and so forth. So let's just go back to positional port connection. So the positional port connection is going to connect the local net names to the ports for the module instances using the same order in which the original port was defined. So this means that when we call a module, we need to know exact ordering of the inputs and outputs and assign the same wires that were in the same order to the port. Here is an example, the reduction AND that we just saw. There is an input A, there is an input A, and there is an output Y. A is 8-bit, Y is 1-bit. And then when we call this in the top-level design, which is shown here, what happens is that we are going to first, call operand 1, which is another 8-bit variable, and then there is a wire. So this also means that as a designer, we need to make sure that we know the sizes of each of these ports and declare them in the same order that was defined in the original design. So here it automatically connects this if we do everything correctly. So this is simple to code, and it's kind of a little bit less hassle, but it actually is an error-prone way because it's not always easy to debug because you always have to go back to the original one and make sure that you follow all the orders as you're debugging. Then if you list the connections in the wrong order in a top-level module, that results in bugs in the program, and that happens a lot in practice, and it's sometimes difficult to manage. You always have to make sure that everybody's using the same name convention and everything, and that sometimes it's hard to keep track of in bigger designs. So what is a better way to do this, and kind of a little bit more professional way, especially if you're writing big program, is to do explicit named port connection. And in explicit named port connection, the module port is explicitly associated with the connected signal, and the way we do that is we put a dot name of the original module name of that signal, and in parentheses we put the parameter that we are passing by. So in the example that we had earlier, if we had the operand 1 and wire C1 that were going to that reduction AND module that was we were calling, what would happen, we would say dot A parentheses operation, operand 1, and dot Y parentheses C1. The good thing is, because this is a dot port connection, we don't really need to maintain the order in this part, in this method. So no matter which order we use, it knows that the A gets assigned to operand 1 here, so it's just going to do its own thing and be correctly connected. So this is the recommended usage, especially if the big design teams are used. There is a disadvantage, which means that, there is, you have to make sure that, you put the name correctly. The names can get long, and you need to specify everything. But the advantage is many, because, this can help making debugging easier. Accidental mistakes happen less in this, and you could use any order. And you could also leave out the unused ports, because sometimes you may not want to use every connection in every module as you're designing. So the unused ports, you don't need to specify wires coming in and out of them. You could also explicitly list them, but you don't need to pass signals. And then the code is kind of self-documenting. It's saying, this is, the wire that is going inside that port that was, in the other design. The .name port connection could be also done, by not having explicit names but having implicit names. In this particular case, we say dot operand 1, which means that this two have the same name. So if you put the name as the same name, then you could mix this with the .name port connection as well. But as you see here, the input here is called operand 1, and the first input here is also called operand 1. If you say dot operand 1, it knows that this is going to get connected to the named variable of the same sort in the submodule that it's calling. So it makes it a little easier, a little less verbose, and you don't need that explicit named port connection. But you could also mix the two. You could mix the explicit named port connection with the dot named port connection. The disadvantage means that you need to make sure that to have the exact name, concise representation, but it's easier to maintain and read. We need to make sure that we declare an exact matching name to that port name before the module instance. So that's something we need to make sure that happens. They must be exactly matching in the size, and the data types should be compatible. So the data types should be compatible. There is another even easier way to do this, and that's a little bit actually something we don't recommend because it is sometimes prone to the error, but a lot of experienced designers use this one, is a dot star connection. When you do a dot star connection, what happens is that it's going to assume the inputs and outputs of the module are exactly the same, and so it's implicit, exactly similar to the previous case where we had the same names assigned to the two of them, but we also could have the here the reduction, and we put dot star means that everything as input and output this had is going to get translated here. So the operand 1 gets connected to operand 1 here. The y is going to get connected to this local, to this one here, and both the top level design and the reduction and module have the same port name and the same local variable. As I mentioned, this is something that a lot of experienced designers do, but not necessarily easy to debug. It's, in big teams, usually they try to use explicit port connection. But of course, the advantage is easier. You just, anytime you specify a submodule, you go and you look at the declaration of the submodule and just put the variables that like the names, and then you just basically do this and connect it. So again, the rule here is to have the same name as port names, and the sizes, of course, they should exactly match each other. So here is an example of an n-bit arithmetic logic unit with explicit name-based port connection. As you see here, we are in the top level module, we declare the variable names, and then when we are calling this submodule here, where we are declaring this submodule ALU here, what happens is that we are going to have this input-output declaration, and then what we do is we just call this opnd1, dot opnd1 comes here, and then operand 1 gets passed by it. And here is, a block diagram of this design if you're interested to look at it. But as you see here, the explicit port names are used in the parentheses, and the dot name connection is used in accordance with the design we had here. So after the synthesis, what it's going to do, it's going to do a correct connection between these forms. In the next set, we will be talking about parameters and how we could use that to freely put data in and out of the modules.